Let me take a small tour for fluid mechanics and hydrology and water resources engineering. Fluid mechanics lab is introduced in third semester civil engineering students, and hydrology and water resources engineering is introduced in the fourth semester civil engineering students. As we have seen that in the other labs, we are care for the student initially for the safety precautions. So we have the fire extinguishers which are installed at just entrance of this laboratory, and move to further inside. And these are the hydrology and fluid mechanics laboratory. We start initially explaining about the vision and mission of this laboratory, along with their timetables, COs, POs, list of the experiments, and along with the posters. We have these two posters which are located on our wall, where we will explain about the initially hydrology and water resources. Yes, so this is the poster where initially we explain the students about the equipments, and later it has maps with course outcome, experiments, and the CO and PO mappings. Similar case we have of fluid mechanics. So fluid mechanics we start from the traditional way by chalk and duster, and later at the same time we are conducting it through the online tool, where we are conducting it in hybrid mode, online and offline, and most of all experiments are conducted by the instrument. So the first important experiment in fluid mechanics, where we initially inform to the students that what means of the viscosity. So this is the viscosity apertures, where it is utilized to finding out the viscosity of the fluids. I will show you the subsequent, the other experiments here. Another experiments we have that the Bernoulli's. So this is the Bernoulli's apertures. All the standardized manual and methods are written here, so that the student initially can aware about that, how the Bernoulli's equipment are used. Later, with support of the lab assistants, we operate this instrument, and then we can utilize to finding out the coefficient of the discharge. These are the other equipments we have. Flow through the pipes, utilize it to find out the friction force in the pipes. The next important instrument we have that orifice and mouthpieces, and subsequently next is to the Reynolds apertures. These are very important equipments for the students, where the students can understand the flow is either laminar or turbulent. So where the students are conducting this experiment on this Reynolds apertures, and then simultaneously we can see the difilaments, whether it is in the straight or in the zigzag ways. And the same here can prove it through the Reynolds equation, Re rho Vd by mu. The next experiment is the venturimeter and orifice meter. Just beside it we have the longest tilting plume, hydraulic tilting plume. It is the 10 meter long, 30 centimeter in height and 45 centimeter in depth. We are conducting the experiments for finding out the uniform and non-uniform flow in this hydraulic fluids. Students are conducting these experiments by finding the velocity distributions by help of this indoor fluid experiments, so which are introduced in fluid mechanics syllabus. In addition, we have like this is the sharing facilities, hydrology and water resources engineering. So, as I said, the rain gauge, this green equipments, we say that it is a tipping type of rain gauge utilized for measurements of rainfall. Beside we have the infiltrometer, helpful for measurements of infiltrations. The next instrument just beside to this hydraulic tilting plume, we have pan evapometer, and which is utilized for finding the rate of evaporations. Later we have the finding the buoyancy force. So we are utilizing the metacentric height and the buoyancy force. So we have one small pontoon here, where the students conducting the experiment and finding out that where the metacenter height are coincide. So this is again very important experiments for fluid mechanics. where student can find whether the ships are in stable condition or not. So these are the major equipments we have where we are conducting all the experiment. In addition, the last that we have advanced computing or simulation lab where student conducting the hydrologic and hydrodynamic modeling, wherein they can learn there how the advanced softwares are utilized in fluid mechanics as well as in hydrology and water resources engineering. I would like to show that some of the ORSP projects student has recently completed, and these are all the experiments ORSP projects the student has completed by using the advanced computing labs.